Today I would like to talk to you about carbapenem-resistant Enterobacteriaceae, also known as CRE. So CRE refers to any member of the Enterobacteriaceae family, such as Escherichia coli and Klebsiella pneumoniae, that are resistant to the carbapenem class of antibiotics. These carbapenems are mostly used to treat people with severe infections in hospitals, and two of the enzymes that break down the carbapenems, rendering them ineffective, are the New Delhi metallo-beta-lactamase and Klebsiella pneumoniae carbapenemase. Carbapenem antibiotics are broad-spectrum, developed in the 1980s, and were used to treat multi-drug-resistant organisms. In the 1990s, when cephalosporin resistance became known, subsequent carbapenem use increased to treat these infections. CRE infections started to show up in the 1990s in the U.S., and in 2013, the CDC reported 3.9% of short-stay acute care hospitals and 17.8% of long-term acute care hospitals had at least one CRE infection in 2012. They are more common overseas due to inappropriate antibiotic use. Population at risk and transmission. So the population are people in hospitals and long-term care facilities, those that are immunocompromised, with multiple comorbidities, diabetics, etc. Infections can occur anywhere in the body, and patients with catheters or that use breathing machines are more at risk. Also, those that are taking long-term antibiotics and extended ICU stays. Transmission can occur through contaminated equipment, improper hand washing, improper cleaning of bedding, so forth. This map shows the prevalence of the top shows carbapenem resistance, and the bottom is third generation cephalosporin from 1999 to 2010. So as the cephalosporins became resistant, the carbapenems began being used to treat these infections and also became resistant. This map shows prevalence of CRE infections with the KPC enzyme pathway as of 2017 January, and only 2 states have not had a reported case so far. And this map shows the transfer of the KPC and NDM enzymes. KPC is endemic in Italy, Greece, Israel, South America, China, and NDM is believed to have originated in New Delhi. This just shows how the enzyme is being brought to different areas of the world. So outbreak investigation. We want to plan the investigation by identifying team members, assign tasks, and conduct meetings. Verify the diagnosis and begin surveillance of the patients in close proximity. Those that are on the same floor or family members need to be identified. Even one case of CRE requires an investigation. You need to choose the appropriate study design and track down the source of the infection to prevent further cases. Determining the source and controlling the outbreak will occur through surveying patients and collecting information, performing investigation of the environmental surfaces and equipment to look for CRE, work with the laboratory to find which particular strain is involved, isolate patients with the infection, and cohort them if necessary onto specific floors, implement control measures such as hand washing guidelines and so forth, and communicate. Preventing an outbreak, infection control is key, so like I said, proper hand washing, decontaminating equipment, using personal protective equipment, appropriate antibiotic use, cleaning, and education. So CRE infections have the potential to be a major problem in the future if action isn't taken now. Up to 50% of those with bloodstream infections die with this infection. The emergence of CRE is serious. Antibiotics available right now to treat the infection are severely limited, so we need to be vigilant about our antibiotic use and develop new antibiotics, because this will only lead to superbugs that have already occurred that are resistant to all available antibiotics. Thank you. Here are my references.